I'm always excited about the presentations that we get here. We have so many talented people that are a part of this organization and that are willing to share information. And tonight, Nick is going to be talking about bug bounty hunting. And this is one of those things that's always just on the edge of my brain. Like, I don't know anything about bug bounty hunting, but I do know that in my threat intelligence feeds, I keep seeing things like Google offering $250,000 for a simple escape in a VM. It's not that simple, but tonight Nick is going to give us an introduction into what he does in this area and just help get us educated. Thank you, Nick.
Thank you. Yep, so just going to be talking a little bit about bug bounty hunting today, kind of at a higher level, introductory style level, just kind of, describe what bug bounty is, as well as a little showcase where we kind of close the gap between your program versus actually finding vulnerabilities. So just the agenda for this afternoon, who am I? We're going to be talking about bug bounty and what bug bounty programs are, a little bit about compensation and incentives, and essentially why someone would want to do bug bounty and why organizations might want to do bug bounty. Talk a little about the opportunity apart from compensation, the opportunity that it provides for people. Talking a little bit about best practices when you're doing bug bounty, and then we're going to run through a practical showcase on reconnaissance. So who am I? My name is Nick Verhelli. I'm an IT security analyst at Raymond. Majority of my work is on penetration testing, but I also do some IT auditing, some IT assessments, that type of thing. I have previous experience in the banking industry as well as health insurance. Got a few certifications there. And then some of the other things I like to do in this field is capture the flags. It's kind of where I started doing hacking. A lot of capture the flags, cybersecurity challenges, hacking challenges, that type of thing. I also really enjoy training, learning new stuff. And then finally, bug bounty is a big hobby of mine, which I'm looking forward to talk to today. So what is bug bounty? It's essentially where you have organizations compensating researchers for reporting the vulnerabilities that they discover on their externally facing attack surfaces. So essentially, you'll have an organization spin up their bug bounty program, and it's usually on a platform. It might be standalone if it's a big enough organization, but oftentimes they use a platform like the three below: HackerOne, Integrity, or BugCrowd. There's a few other platforms, but those are the big three. And your platform is essentially where you're connecting your organization and their program to your ethical researchers or bug bounty hunters. And so there's a few different types of bug bounty programs. There's an actual bug bounty program, and then there's a vulnerability disclosure program. The main difference is compensation. So you can have a bug bounty program, and that'll pay you, monetary, so you can make money off of the bugs you submit. It can pay you based on tangible goods. So for example, Red Bull, they don't pay you money, but they'll ship you cases of Red Bull depending on how severe your vulns are. So if you submit a critical, you can get like cases and pallets worth of Red Bull, or if you get like a low, they'll send you like a single case. And essentially your platform is your platform that has your hacker connected to your organization. And that's where usually you have your hackers submitting your vulnerabilities. The organization usually that's where they're triaging their vulnerabilities. And then that's where usually the payouts occur for hunters. There's also public programs and private programs. So a public program it's kind of open to anyone who to anyone, the public. You can, whether it's Microsoft with their own standalone program, anyone can submit vulnerabilities to it. If it's a public HackerOne program, you just got to be a user of HackerOne and you have access to it. Private programs are a little more special. You actually have to have invites to them. That helps people because hackers have less competition. If there's less people looking at the attack surface, you're probably more likely or have a better chance of finding vulnerabilities or assets that other hackers haven't looked at before. The overall goal and why an organization would want a bug bounty program is because it's like crowdsourcing your security. You can have all these amazing minds that are looking at your attack surface to help find those vulnerabilities that your security team might not have the time or energy to deep dive into. So these are the main domains of bug bounty, essentially the different areas that ethical hackers might be interested in and the areas in which they're going to be looking for vulnerabilities. A large majority of it is going to be your web applications or your websites that are publicly facing. There's also tons of networks, so organizations might include all their network infrastructure into their bug bounty program. You have your mobile apps, so they're your mobile applications that you might find bugs in. There's also smart contracts, crypto, Web3, that's all kind of looped into bug bounty as well. even hardware hacking. Some places will ship you hardware. Open source code. So if you want to include your open source Git repositories into your bug bounty program that they're public, you can do that. OS, like I mentioned, Microsoft has it for Windows. Something newer, there's not many of them, but sometimes organizations will pull in their AIs, like if they have a AI chatbot on their main webpage, they'll pull that into their bug bounty program. If you're able to do something funky with that, that's impactful, you can provide a report for that. One thing that's not talked about much is leak credentials. So it's not really something that is public, like on organizations' web or on their programs, but oftentimes they might accept if you're able to find on the dark web or somewhere where someone is broadcasting these breached credentials, like on Telegram channels or something. If you have that skill of being good at finding those breached credentials and you're able to validate those and then submit them, then you might get a bounty for that as well. So talking a little bit more about compensation and incentives, the main thing being monetary rewards and tangible goods. I pulled these metrics from the HackerOne 7th edition of their security report, where 80% of bug hunters are hacking purely for the money. And then you actually have a subset, 47%, who are actually hacking to protect the businesses, to find vulnerabilities so that you can secure your organization and actually protect end users. There's also, on these platforms, a reputation or point system. These platforms have gamified bug bounty to a degree to where if you are submitting different severity bugs, you get different amounts of reputation or points, and then you can gain, steps on the leaderboard, and you might get number 1 for a program or number 1 for HackerOne. You could be a top hacker, they say. It also helps specifically in invites to private programs. If you're able to get tons of reputation or points on the platform, you get invites for private programs, and then you're able to have new attack surfaces that you didn't have beforehand. So I pulled PayPal's bounty table. This kind of gives you a glimpse of the scale at which you might be able to make money off a bug bounty. PayPal has a public program. You can see that if you have a low submission, you could get paid from anywhere to $50 to $1,000. Bounty payouts are usually based on the severity or impact of your bug. So less impactful gets paid less, more impactful gets paid more. And a lot of times it's up for discussion on how impactful or how severe a bug is, but a lot of times that's what translates into your payouts. So as you can see, criticals, if you submit a single critical vulnerability bug on PayPal's program, it might pay out $20,000 to $30,000, which is a very large sum of money. And so you can tell why some people actually do bug bounty for full-time jobs, because if you're able to find 3, 4, or 5 critical vulnerabilities on big programs like PayPal, you can make a large salary for that. So just wanted to cover that a little, give a little perspective on that. This is these screenshots are specifically taken from HackerOne, which is what I normally hack on. So I pulled them from there. A little more, just a glimpse of what the program actually looks like. So this is PayPal's. You have their button up there to submit a report. It also will provide you some metrics on the program, so the response efficiency, how quick they are to triage your bug, how quick they are to give you your bounty, that type of stuff. You'll have your bounty table. And then this overview section is super important. It's essentially going to be all of your rules of engagement. So what you're allowed to do, what you're not allowed to do. They could have rules on, you have to add a specific HTTP header into all of your HTTP requests, so that they are able to track you apart and separate you from actually malicious hackers who are attacking them. It'll also outline what vulnerabilities they're interested in versus what ones they're not interested in. And so that kind of helps you when you're testing to not waste your time searching for something that they're not gonna, pay out for. Just another glimpse on the scope. So this is your scope page. This is specifically the assets that are in scope or specifically excluded from testing. So you have your different assets and the different type of assets. So like they have mobile assets. They've got also domains and subdomains in scope. You can also tell whether it's in scope or out of scope, specifically excluded with the coverage. You'll see your max severity. So that's actually, you can be fine grained about how you want to pay out for different assets. So all of these, if you submit a critical vulnerability, you're going to get paid out at a critical level. Whereas some of them, you could submit a critical vulnerability, but it'll only be paid out at max, a medium, or moderate. You can also specifically exclude or include a asset for bounties, and then some other stuff like the last update and how many resolved reports it has. So talking a little bit about the opportunity it presents for hackers as well as organizations. Essentially, bug bounty provides hackers with real-world attack surfaces where they're able to apply their methodology from something other than like a CTF, from which I started, like hacking something that you know is already vulnerable, that type of thing. When you're able to when you have this opportunity to attack a real-world attack surface, you are going up against the entire organization's security team, security engineers, everyone who's trying to harden this attack surface. And so that's who you're going up against, and it makes you're forced to build a stronger methodology, be more efficient with your testing, and grow your knowledge. Like I mentioned, it's possible to make it a full-time job if you're super good at bug bounty and you're able to get a lot of payouts, that type of thing. What's really cool about bug bounty is the recognition and awards that you can get for it. So if you like submitting, or if you have multiple bugs that you have submitted before, or vulnerabilities, you could throw those on your resume, because it shows that you have real-world experience and have found real-world vulnerabilities that have had an impact for organizations. The DoD specifically does this Researcher of the Month thing, which they select, based on whatever vulnerabilities you've submitted or the entire community has submitted to your program. They'll select a Researcher of the Month. This was mine, but I'm being honest, and I didn't think I submitted anything that was super impactful, but they must have thought so. But what I'm saying is it's obtainable. It's not something that's out of reach. And so it's a super cool opportunity for people. And then finally, I want to talk about impactful security research. So you are having organizations who are now giving many people the permission to attack them, right? So you are now given the opportunity to attack tons of different organizations, and you have that permission to do so. So now let's say if you're really into finding 0 days, you could develop a 0 day and you could test it against all these different organizations and see how impactful that is. Usually you would probably want to disclose it first and then have the patch come out and then spray it across, but it just aids in that impactful security research that some people like to do. Obviously, if you're attacking organizations, there is a certain level of risk for yourself, right? Obviously, if an organization isn't forcing you to create, a specific HTTP header in all of your requests, how are they going to determine you're not, someone who is maliciously attacking them? And that usually, it is a certain degree of risk, and there will always be inherent risk with it, right? Trying to avoid legal action or something taken against you. There is this concept of safe harbor. It's kind of like a statement or policy that programs will put into their overview and summary that basically says, ethical researchers can conduct good faith security research and attack us against our externally facing attack surface, whatever is in scope, without having legal action taken against them. And so the DoD does this. Tons of programs do this because they want to close. They want to minimize the amount of risk that they're posing to these ethical researchers. The more risk you have, the less people are going to hack on you, and then that avoids the whole reason you have this program. So some best practices: always prepare when you're doing bug bounty in your programs. You want to make sure that you actually understand the rules of engagement in your scope and what you should and should not be doing. You also want to specifically understand how to not waste your own time. If they're not going to, accept a vulnerability, why are you going to try to test for specific vulnerabilities? A good example is like reflected XSS or cross-site scripting. A lot of times they might not accept reflected cross-site scripting because it's not that impactful. They don't want to waste their money on it. And so they might throw that in their overview to tell you, don't submit that to us because we're not going to pay you for it. Hack responsibly, obviously. You want to make sure that you're not disrupting anything. You're not, causing any denial of service. You're not destroying data. You're not doing this or that. That might damage the confidentiality or integrity or availability of the assets that you're trying to find vulnerabilities in. You're trying to be helpful, not hurtful, essentially. Writing clear reports kind of helps everyone. It makes you get your money faster, helps triage your bug faster, all that good stuff. It helps the organization way better. And it kind of comes into this fourth bullet point, or POC or GTFO. If you're not submitting a proof of concept with your vulnerability and your bug, they're either going to ask it of you, or they will likely set it as informative, or essentially that this was not a bug. The whole reason is that your proof of concept is like how you exploit this vulnerability, what impact it has. It directly shows the impact that your vulnerability has. If you have no POC, you can't really demonstrate your impact, and they pay based on impact. So if you can't demonstrate that, you're probably not going to get paid. POC or GTFO. All right, now we move into the practical showcase. the recon. As a disclaimer, I'm not actually showing any vulnerabilities, and I'm not going to be showing any indicators of vulnerabilities, just purely reconnaissance. And we're going to be doing it against the Department of Defense. So they're a vulnerability disclosure program, as I mentioned. They're not paying for these vulnerabilities, but you do get reputation on HackerOne for submitting valid vulnerabilities to them. It's known as a good program to practice on. Essentially, the DoD has tons of assets that are available online, and there's a lot of low-hanging fruit to a degree. And so it's a good place to kind of get your feet wet, practice some methodology, and find some decent bugs. So we're going to walk through a little piece of what I do for reconnaissance at a higher level, to provide a little more context to bug bounty, and kind of talk about close the gap between my program and actually finding vulnerabilities on those assets. So you could start with autonomous system numbers. Essentially, they're groupings of IP prefixes or network ranges that are grouped together and can be provided to organizations by their ISP. So essentially, larger organizations will do this, usually to help their internet routing. There's this website, bgp.he.net, that you can go to. And so what I did was I went to that website and I searched for the .mil top-level domain. That .mil top-level domain, or military domain, is owned by the Department of Defense, and it's only Department of Defense assets. And so what I did was I searched for it, and I see that it is specifically delegated to the Department of Defense Network Information Center. So what I did was I then took that, searched it again on the website, and then I got a listing of all their ASNs. That's just a small clip of them. There's actually 973 ASNs that the DoD has. For context, this is what one ASN looks like. That's all /24s, but it also includes /8s and /16s. Specifically, AS367 has 2,669 IPv4 networks. Not just IPs, but actual networks, which is a very large amount. And so if we wanted to test that, we could. It'd probably take forever. So we could probably pivot to subdomain enumeration, essentially taking all of the root domains of .mil and then trying to find all the subdomains of those root domains to try to find any publicly available assets. So what I did is I went to cert.sh. Essentially, it's a certificate search application. It's a database of issued certificates. And we can search for the .mil top-level domain, and we can get tons of random certificates that have been issued in that top-level domain. You can see like the U.S. Coast Guard, Navy, that type of thing. I don't want to purely go off of this as the only source of my subdomains. So what I did was I chopped all those subdomains off and just gathered all of the root domains or apex domains for the .mil top-level domain. So now we can move into subdomain enumeration. This is kind of a small clip of what our root domains look like. So Air Force, AFIRM, .mil, that type of stuff. We found that there were specifically 100 root domains that I was pulling from cert.sh, and we're going to use a tool called Subfinder. So Subfinder is a subdomain enumeration tool. It's passive. It's going to go out to public sources that have subdomains ready for people to search. And it's going to take those from tons of different sources. It's all going to give it to us. And it's all passive, like I mentioned. So we're not actually touching any DoD name servers or resolvers or anything like that. If you wanted to, you could perform active reconnaissance and brute force, DNS records on those servers. But for this talk, we're specifically just doing passive reconnaissance. And Subfinder is actually created by an organization called Project Discovery, who does amazing work. They build all these awesome open source tools that are great for both penetration testing and bug bounty hunting. And so I ran Subfinder specifically against all those root domains, and we found 45,618 subdomains from those root domains. And so that was just passive. So we're probably missing a few, but we can move on with that. And now we want to see, okay, out of all those subdomains, which ones are actually live? What is actually pointing to a real host? And so we're going to use the second tool from Project Discovery called DNSX. So this is kind of what our subdomains look like, and we're going to pipe them all into DNSX to basically, DNSX is just going to resolve them. Just say, hey, does this resolve to something? Does this resolve to an IP address? And so from that, we got rid of a decent amount of subdomains. So now we actually have 29,456 that resolve to something. Now we're going to see, okay, I want to start testing web servers, or I want to start testing network services. whatever you want to do. Your methodology might split from here. If you're looking for vulnerable SSH services that are public, you could do that. Specifically, I like hacking web applications, so I'm going to use a tool to help me find more web servers. So I'm going to use HTTPX, a third project discovery tool. Essentially, it's going to create tons of HTTP requests to all these different ports, specifically all the ones I put in my command, to try to find live web servers and what's going on with those.
What's the end of this command there?
Yep. So I didn't have enough room in my screenshot. Essentially, they are all additional flags that you can set in your command to find additional metadata. So as you can see, I wanted to grab the title that's provided in the HTML of the response. I also wanted to grab the server header that's responding from the website to see if I can, is it Apache server, is it Nginx, that type of thing. I have my notes for the other ones. So the IP that the subdomain resolves to, the content length and content type of the HTTP response body that's sent back to you. You can also get your response code. So whether you get a 200 response code or whether it's a redirect with the 302. If it is a redirect, we also grab the location that it's redirecting us to. And then we can grab the response time. So how quickly or how slowly that response is getting back to us. So this is the results of HTTPX, just a small portion of it. We actually found 2,483 web servers. Some of those might be duplicates, so you might have different URLs pointing to the same server, but this is what the HTTPX results look like. And so you'll see you have this 11th Airborne Division.army.mil website that gives us a 200. It's running HTML response to us. And we can see the title is the homepage for the 11th Airborne Division. You can also see sometimes you have web servers that are being fronted by Akamai. And so usually you don't want to target Akamai because you'll probably get your IP banned, stuff like that. And so at this point, this is where your methodology truly comes out, right? There's tons of different ways you could go about testing when it comes to bug bounty. Some people like automation and mass automation. So you could take all of the web servers you found and perform massive vulnerability scanning against everything and go super in depth. Or you could pick one of these and go super in depth into that one specific web server or web application. It's really how you want to go about doing it. For us, we're going to look for specific technology. So personally, I like hacking on PHP web applications. And so I want to see what is out there that is running PHP on those web servers. So I'm going to use a tool called Nuclei. I'm sure there's a few different ways to go about finding which are PHP applications. I'm going to go about using Nuclei, which is a fourth tool from Project Discovery. It's a vulnerability scanner. That's their most popular tool, really, that they published that allows you to create custom YAML templates. There's also a large repository of templates that they've published, but you can use these to test for different attributes of a web server and see, get different results. So for example, using all of their technology templates, we see that some of these are running Akamai, some are running Dreamweaver, some are running PHP, that type of thing. So we use that, and looking at the results, we cat out our output and we grab for PHP so we can see the PHP applications. And we got a few. We've got specifically looking at this AF legal assistance.law.af.mil is running a PHP application. It's running an Apache server, which we can see from this output, and then it's running 7.4.33. And you can see some other versions like 8.1.29 on other applications. And if we wanted to pick a target like that website, we could start testing against this website. So the U.S. Air Force Legal Assistance homepage, we want to now enumerate this web application. So what is actually all the functionality that we have? Where are all the endpoints? What are the parameters on those endpoints? That type of thing, in order to find exactly what we can do for this. And this is definitely where more methodology comes in and how you test for vulnerabilities in different vulnerability classes. So for example, we could look for all the known URLs. So known URLs is similar to kind of passive subdomain enumeration. You're going out to public sources to grab all URLs that have been publicly cached or stored in different databases that are accessible to look for different endpoints on that subdomain or that web server that we're looking at. So we use a tool called Waymore by XML Hacker, which is an amazing tool that will search. For example, it goes back to Wayback Machine. It'll also go to VirusTotal and URL Scan to grab these endpoints. And so, for example, we could see like they have a robots.txt at this endpoint. They have faq.js off of their JS repository, that type of stuff. It really becomes helpful if you have a web application where you can't actually find the root of your web app. And so if you're unable to find the root of the web app, you're not going to be able to find any of the functionality. But potentially, if someone else has found it previously, and it's been cached somewhere or stored somewhere where you can then find that endpoint or the application. You can also perform directory brute forcing to find additional endpoints. And so, for example, I saw in the known URLs that there was this JSON directory off of the application. And so I'm going to use this tool called FUF, or Fuzz Faster You Fool, to fuzz for all of these directories. And so I'm going to specify my URL. I'm going to specify fuzz for specifically where I want my input to be placed at. And I'm going to use a custom word list I created. I'm going to actually auto-calibrate the results of what's getting back to me. And I'm going to make sure that I'm also testing for anything with a .php at the end. And so we actually ended up finding 6 different endpoints. And it gives you a little more data to work off of based on those endpoints. So something that's interesting is having this basis.php returns a very large HTTP body compared to like index.php, which actually redirects this, or topics.php. You also have feedback.php, which gives us a 500 error code, which makes me think we're not giving something else to the server that it might need to process that request correctly. So stuff like that you're kind of looking for these additional endpoints where there might be other functionality that might not be very obvious to the end user, but that we might be able to attack. Finally, web crawling. You could crawl the web application, see all of the endpoints that have been published in the actual HTML of the page. We use a tool called Katana, which actually does both HTML and JavaScript parsing. Katana is another tool by Project Discovery. And it will go through the web application, it'll crawl it, and it'll also look at your JavaScript files and parse the JavaScript to try to find additional URLs for you to hack on. So we have more endpoints. We also have parameters for those endpoints and different stuff we can test on. And now at this point, it's kind of going into the hacking portion where you're going to start trying to exploit different endpoints. You're going to try to make the application's logic break down. And that's where your hacking methodology comes in, apart from your reconnaissance. Your reconnaissance is essentially, how am I getting to the area where I can actually do something to this application and create impact or exploit a vulnerability, that type of thing. So I showed you some reconnaissance. There is probably like 100 or 1,000 different additional steps you could take, because this was not an all-encompassing methodology. There's definitely additional steps that you could take to better your results and your accuracy when you're trying to find all these endpoints on your application and mapping it out. So that was the end of the presentation. Any questions?
What did you find to get that to work?
I tried disclosing them, prior to this presentation, but I was unable to get them disclosed before then. They were access control issues on different web pages.
Okay.
I think there were like 2 different web apps.
How long did it take for you to get to that point, from start to finish?
That one was 10 hours.
Straight through?
I think it was like 5 hours. I took a break, came back for another 5 hours. I think I had a free day. I was just like, I'm just going to do this. I'm just going to keep going. But yeah.
What's your proudest win?
What's that?
What's your proudest win?
Oh.
Not the biggest, but the one that you're most proud of.
Yeah. Well, my proudest win was one that wasn't informative. I didn't even get a bounty or anything out of it. They didn't even mark it as a high. I was poking at an artificial intelligence bot on a web page. I got it to tell me how to make meth. and I was basically the process is if a malicious actor can come in and use your AI bot maliciously to create, whether it's phishing emails or just malicious content, that has some sort of impact to the organization, whether it's reputational or that type of thing. And even the triager that responded was like, yeah, you can get an arbitrary response from the AI, but in reality, it wasn't that impactful for the organization that someone was able to do this. And so they marked me as informative, but that was super. I really enjoyed that one. Yes, you're right. You're right. Yep.
So how long have you been making that? Those must be any good.
Yeah.
What would you say is the most common bug that you've found or your favorite?
My favorite to look for is access control issues, usually trying to bypass, authentication mechanisms using other things, whether it's they've input a valid session into the HTML and you can just pull out the valid session and throw it in your cookies or whatever it is that way. The access control is fun. There's actually a tool called, if anyone's familiar with Burp, it's a web proxy. There's a tool called Autorize, which if you can log into an application, you can test for the access you currently have, and also the access that is unauthenticated. So it'll remove your cookies. And so for example, if I'm making a single request to an endpoint, it'll try with my cookies that are authenticated and also create a duplicate request, but with those cookies removed. And so for example, if you try to query a database and you can see, oh, I can do this actually unauthenticated, then I have an access control issue. So that is super fun to use, and it'll light up my Burp and it'll give me all these cool colors. So it's great.
Have you or do you know others that have participated in these activities? Are they collaborative with others?
They are very collaborative. There's entire tab on a program that is specific to collaboration. And so you can work with other hackers to find vulnerabilities. There's even these live hacking events where people come together and try to produce as many vulnerabilities as possible. And then you can do things like split bounties, different percentages, that type of thing.
Do you feel like this has helped you at all within your day job?
Definitely. I started doing this before I got to my day job, and it really helped me kickstart my methodology. And it also helps me get knowledge to apply to my methodology, especially when it comes to reconnaissance and attacking external attack surfaces. Having this knowledge of bug bounty and how to find interesting stuff to poke at is super helpful. So.
Could you expand a bit more on the Maki Ghost service? That's just something that I haven't heard.
The what servers?
The Maki Ghost, you said?
Oh, yeah. So Akamai is a cloud provider, but they also have a really tough WAF. And so I have a funny story. I started bug bounty, and I was just trying to find my first vulnerability, and I didn't do anything like proxy my HTTP traffic through like a cloud server or use a VPN or anything like that. I was just for my parents' home internet. I started attacking some web servers that were fronted by Akamai. And so what Akamai does is that essentially all their traffic and your requests will go through Akamai before reaching the web server, and they will detect if they're malicious. And so Akamai has a massive ban list that it applies to all of its web servers. And so if you're doing, malicious traffic, just trying to test like some random, organization that has a small program, but they use Akamai, it'll ban you when your parents try to go to Hulu, because Hulu uses Akamai. Yep. So essentially, it's a large WAF, but they provide additional security solutions for organizations, and a lot of times you'll see them when you're doing bug bounty. And I try to stay away from them from personal experience. So,
That makes sense.
yeah.
Always use a VPN.
Yeah.
Always.
With testing web applications, do you ever do anything with like web hash poisoning?
That is something that I've heard tons of people testing recently, and I have not learned about it yet. It's something that I really want to learn about because it sounds like you could do some pretty crazy stuff with. I know like kind of the gist of it and some nuances there, but it sounds super cool and something I need to look into.
Yeah, it's one of those things where, there's just so many different openings because people don't fully create their headers properly.
Yeah.
And you can end up redirecting, like getting things cached on the server that redirects and basically temporarily takes over the website. So,
Yeah.
Yeah, that's, I guess it's going to be a big thing coming up here.
Oh yeah, definitely. Awesome. Well, thank you for listening. Appreciate it.
I could have listened to that for like another hour.